Welcome back to the channel. Today we're diving into the world of batteries, specifically a potential successor to the lithium-ion batteries we all know and use every day. We're talking about sodium-ion batteries here. You know me, I'm all about pushing the limits of tech, and honestly, battery tech is one of the places we need some serious innovation. So, let's break down 5 surprising advantages of sodium-ion batteries that might just make them the future of energy storage. Alright, let's talk about the elephant in the room when it comes to new tech cost. It's something that can make or break the adoption of new technologies. Whether you're a tech enthusiast or just someone looking to upgrade your gadgets, the price tag is always a crucial factor. One of the biggest advantages of sodium-ion batteries is their potential to be significantly cheaper than lithium-ion batteries. This isn't just a small difference we're talking about, it could be a game changer for the entire industry. Imagine being able to power your devices with batteries that cost a fraction of what you're used to paying. Why? Well, it all comes down to raw materials. The elements that go into making these batteries are what drive the cost. Lithium, while relatively abundant, isn't the easiest thing to mine and process. The extraction process is complex and often environmentally damaging. It requires a lot of energy and resources, which naturally drives up the cost. Plus, the demand for lithium is skyrocketing, which only adds to the price. Sodium, on the other hand, is everywhere. It's one of the most abundant elements on Earth. You can find it in oceans, salt flats, and even in the food we eat. The extraction process is much simpler and less costly compared to lithium. We're talking oceans, salt flats, you name it. This abundance means that the raw material cost for sodium-ion batteries is significantly lower. It's not just about the availability, it's also about the ease of extraction and processing. This abundance translates to a much lower cost per unit, which is a huge win for making sodium-ion batteries commercially viable. Lower production costs mean that manufacturers can produce these batteries at a fraction of the cost of lithium-ion batteries. This could lead to cheaper consumer electronics, electric vehicles, and even renewable energy storage solutions. I mean, who doesn't love more affordable tech, right? Imagine being able to buy a new smartphone, laptop, or even an electric car without breaking the bank. The potential savings are enormous, and it could make advanced technology accessible to a much broader audience. This isn't just about saving money, it's about democratizing technology and making it available to everyone. Think about the impact this could have on developing countries, where the cost of technology is often a barrier to progress. More affordable batteries could lead to wider adoption of renewable energy solutions, reducing reliance on fossil fuels, and helping to combat climate change. It's a win-win situation for both consumers and the planet. And let's not forget about the job opportunities that could arise from this shift. As the demand for sodium-ion batteries grows, so will the need for skilled workers to produce and maintain them. This could lead to job creation in various sectors, from manufacturing to research and development. Speaking of research and development, the lower cost of sodium-ion batteries could also spur innovation. With more affordable materials, researchers can experiment and push the boundaries of what's possible, leading to even more advanced and efficient battery technologies in the future. So, the next time you're shopping for a new gadget or considering an upgrade, think about the potential impact of sodium-ion batteries. They could make your tech more affordable, more sustainable, and more accessible to everyone. The price is right and the future looks bright. Speaking of abundance, let's talk about the environmental impact. When we think about the future of energy storage, it's crucial to consider not just the efficiency and cost, but also the environmental footprint of the materials we use. Lithium mining can be pretty harsh on the environment, requiring large amounts of water and energy, and often leaving behind some not-so-great byproducts. The process involves extensive mining operations that can devastate local ecosystems, deplete water resources, and generate significant amounts of waste. In regions where water is already scarce, this can lead to severe environmental and social issues. Sodium extraction, however, is a much cleaner process. Unlike lithium, sodium can be extracted from abundant sources like seawater and salt flats, which are far less disruptive to the environment. The extraction process itself is simpler and less resource-intensive, making it a more sustainable option. Remember those salt flats I mentioned? These vast natural deposits of sodium are not only plentiful, but also relatively easy to access. The extraction process from salt flats involves evaporating water to leave behind sodium compounds, which is a low-energy and low-impact method. Yeah, extracting sodium from there is way less energy intensive and has a much smaller environmental footprint. This means less disruption to the local environment and a more sustainable approach to sourcing materials for batteries. The minimal energy required for extraction translates to lower carbon emissions, making sodium a greener alternative. Plus, sodium is much less toxic than lithium, so there's less risk of contamination if something goes wrong during manufacturing or disposal. Lithium, on the other hand, poses significant risks due to its reactivity and potential for environmental contamination. Sodium's lower toxicity means safer handling and fewer environmental hazards, which is a significant advantage. So, from an environmental standpoint, sodium-ion batteries are looking pretty good. They offer a promising alternative to lithium-ion batteries, combining efficiency with a much lower environmental impact. As we move towards a more sustainable future, the adoption of sodium-ion technology could play a crucial role in reducing our ecological footprint and promoting greener energy solutions. Now let's talk safety. We've all heard those horror stories of lithium-ion batteries overheating and, in some cases, catching fire. While those cases are relatively rare, it's still a concern. Sodium-ion batteries, however, are inherently safer. They're much less prone to overheating, and even if they do, they're less likely to catch fire. This is because sodium is less reactive than lithium, so there's less risk of a runaway thermal event. This increased safety is a major plus, especially when you think about applications like electric vehicles or home energy storage where safety is paramount. Another key advantage of sodium-ion batteries is resource availability. Remember how I said lithium isn't the easiest thing to mine? Well, lithium is concentrated in a few regions around the world such as South America, Australia, and China. This concentration means that any geopolitical issues, trade restrictions, or natural disasters in these areas can severely impact the global supply of lithium. This limited availability can lead to significant supply chain bottlenecks and price fluctuations. For instance, if a major lithium-producing country faces political instability or decides to limit exports, the entire global market can be thrown into disarray. This unpredictability makes it challenging for manufacturers to plan and scale their production efficiently. Sodium, on the other hand, is readily available all over the world. Unlike lithium, sodium can be found in abundance in many countries, including the United States, India, and various parts of Europe. This widespread availability ensures a more stable and reliable supply chain. This means we're not reliant on a few specific countries for our supply, which is a big deal for global stability and security. By diversifying the sources of raw materials, we can mitigate the risks associated with geopolitical tensions and trade wars. This also allows for more competitive pricing and reduces the likelihood of monopolistic practices in the market. Additionally, the extraction and processing of sodium are generally less environmentally damaging compared to lithium. Sodium can be sourced from seawater and other abundant natural resources, making it a more eco-friendly option. This is crucial as the world moves towards more sustainable and green technologies. Plus, it means we're less likely to see those crazy price spikes that can happen with rarer materials. The price stability of sodium-ion batteries makes them a more attractive option for both manufacturers and consumers. Over the long term, this can lead to more predictable costs and better financial planning for companies involved in the production and distribution of these batteries. So, from a resource standpoint, sodium-ion batteries are a much more sustainable option. They offer a viable alternative to lithium-ion batteries, especially in applications where cost and resource availability are critical factors. As technology continues to advance, we can expect sodium-ion batteries to play a significant role in the future of energy storage, contributing to a more sustainable and resilient energy infrastructure. Finally, let's talk about performance in cold temperatures. One of the downsides of lithium-ion batteries is that their performance can degrade significantly in cold weather. This is because the chemical reactions that power the battery slow down at lower temperatures. Sodium-ion batteries, however, are much less affected by cold. They can operate efficiently even in sub-zero temperatures, which is a huge advantage for applications like electric vehicles in colder climates. Imagine not having to worry about your electric car's range plummeting in the winter. So, there you have it, 5 surprising advantages of sodium-ion batteries. While the technology is still under development, it has the potential to revolutionize the way we power our devices and our lives. Cheaper, safer, more environmentally friendly, readily available, and better cold weather performance. Sodium-ion batteries might just be the future of energy storage. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more tech insights. See you in the next one.